Good afternoon, everyone. My name is Joaquin Esquivel. I'm chair of the State Water Resources Control Board. Today is Wednesday, November 17th. It is, I should have said, did I say good afternoon? Anyway, it is 1 p.m. and I'd like to call this meeting back into order. I'll begin by introducing my fellow board colleagues with me here today. Joining me today are Vice Chair Doreen Diadamo, Board Member Sean McGuire, Board Member Laurel Firestone, and joining by audio is Board Member Nicole Morgan. With us here today is also our Executive Director, Eileen Sobek, our two Chief Deputies, Eric Oppenheimer and Jonathan Bishop, our Chief Counsel, Mr. Michael Loffer. We also have here our Clerk of the Board, Janine Townsend, and assisting her today is Margie Argel and Courtney Tyler. As you can see, this meeting is being webcast and recorded. You are either viewing us here one of two ways. You are on our traditional web streams on Cali, PA, or on YouTube Live, or you're here on the Zoom platform with us. If you intend on commenting on today's workshop on microplastics, then you should be here on the Zoom platform. There are instructions on how to do so at the top of today's agenda. Or if you're having challenges, you can email comment letters at waterboards.ca.gov, and our clerk of the board will help you get here onto the platform. And while you're here on the platform, you'll be muted. Your camera will be off until it is your turn to speak on an item. And with that, I think we can move straight into then our single item of today, our microplastics, our public workshop on the method and testing and reporting plan for microplastics in drinking water. And here to start us off is Darren Pohamis, our head of the Division of Drinking Water. Good to see you. Good afternoon.
Thank you, Chair Esquivel. I do want to get us started today with just saying how momentous this is to be able to present this to the board. This is some work that has international and national significance. California is really leading the way here, both in drinking water and environmentally. And you'll see from Dr. Coffin's presentation shortly, all the great work went into that to get us to this point. I will say that while we didn't get all the answers we wanted, this work really does pave the way. And I believe you'll see that for getting answers much quicker into the future around the health consequences and other things associated with microplastics in drinking water. Certainly there's more information already available around its water ecology impact and the likes. But today we'll be focusing on drinking water and how to continue to move that forward. We've been moving them forward in parallel to make sure that we share our resources, the state's resources, as we do this work and go forward. So with that, I'm going to let Dr. Coffin take over and do his presentation, and then we can pick up from there with questions from the board members as well. So Scott, if you'd like to take it away, please do.
Thank you, Darren. Good afternoon, Chair Esquivel and members of the board. My name is Dr. Scott Coffin from the Division of Drinking Water, and I'll be providing an informational presentation today regarding our proposed standardized analytical methods and a testing and reporting plan for microplastics in drinking water. Next slide, please. Microplastics are a ubiquitous contaminant. The first study to monitor for microplastics in tap water in 2017 found these particles in 83% of samples worldwide and 94% of samples in the United States. Next slide, please. Findings of microplastics in drinking water, as well as an increasing public awareness for our exposure, prompted the California legislature to pass Senate Bill 1422 in 2018. This requires the State Water Board to first define microplastics by July 1st of last year, and by July 1st of this year, we are required to adopt a standardized method for monitoring, accredit laboratories, consider adopting a health-based guidance level, and adopt a plan for 4 years of testing and analysis. Next slide, please. The State Water Board adopted the world's first regulatory definition of microplastics in drinking water on June 6th of 2020. This definition is broad and includes particles between 1 nanometer and 5,000 micrometers. We have an additional size-based classification scheme shown here. Next slide, please. At today's board workshop, we will be discussing the additional requirements of Senate Bill 1422, which again included the development of a standardized method, consideration of a health-based guidance level, accreditation for labs, and 4 years of testing and analysis. We recognize that the July 1st deadline for these requirements has passed. Our method development project experienced some significant delays that were due to COVID, as laboratories were unable to process the samples as they were shut down. Despite this setback, we believe that progress through this research effort is significant and will fulfill the requirements of Senate Bill 1422. I will start by detailing our development of standardized methods. Next slide, please. First, I'll give you an overview of how microplastics are analyzed in a lab. The laboratory process for analyzing microplastics in water is relatively straightforward. Plastic particles, as well as other particles, are extracted from a water sample using filters, and particles are then identified and categorized using a microscope. Pictures and measurements of particles may be taken for further analysis. And finally, chemical analysis is performed on some or all of the particles to determine if they're plastic or some other component. Common chemical analyses include light-based spectroscopic techniques such as Raman and infrared. Next slide, please. Something important to understand about these techniques that are widely used for detecting microplastics is that they are size dependent, with smaller particles being more difficult to detect. Microplastics that are smaller than 1 micron, which is about the size of bacteria, are challenging to detect with most spectroscopic instruments. While other techniques are available to quantify these small particles, they are less developed than the spectroscopic techniques are. Next slide, please. Oh, sorry, next slide. Just hit one more time. There we go. When Senate Bill 1422 was passed, there were no standardized methods for monitoring microplastics anywhere in the world. We filled this gap by working with the Southern California Coastal Water Research Project, or SWRCB, to facilitate an interlaboratory validation study. The goals of this project were to determine the strengths and weaknesses of a suite of methods. To do this, laboratories measured known blind samples using standardized protocols for several candidate methods. We quantified the accuracy and precision of each method and tracked the time and costs required to complete each of these methods. We also collected information about the laboratory's experience level and instrumentation. Next slide, please. This was really an international effort. We had 26 participating laboratories from 6 different countries, with representation from academia and government, as well as industry. Next slide, please. We assessed 5 methods in this study, including visual microscopy with and without Nile red dye, Raman spectroscopy, infrared spectroscopy, and pyrolysis gas chromatography with mass spectrometry. We only had 2 laboratories that submitted data for the pyrolysis GCMS, so we could not assess the precision and accuracy for those methods. Next slide, please. Laboratories were sent blind samples that contain realistic mixtures of particles found in drinking water. 4 common plastic polymers were used, each in varying size amounts and 4 different size fractions, ranging in sizes from 1 to 1,000 microns. We also added false positive materials like sand and shell fragments to test the robustness of the identification methods in determining plastic or other materials. It's important to note that these samples were made specifically for this project, and there's no proficiency testing samples for microplastics anywhere in the world right now. We worked with a group in Norway to develop samples for this one project, but no one else is making these at the moment. Next slide, please. So looking at the data that laboratories sent back to us from these blind samples, we can see the performance of the methods based on different parameters. So first, looking at the overall findings for all particles on the left, we can see the y-axis is the percentage recovery, and the dotted line shows the 100% mark. So the closer the recovery is to 100%, the more accurate the measurement is. We can see that the grouping of data reflects the precision. So on the pane for the left, there was relatively low recovery and low precision for all particles, but this is not the whole answer. If we look at the second pane in green, we can see that there are differences based on size, with good precision and accuracy for particles that are larger than 20 microns. Also, when we break it up by color, we can see that there is higher recovery than expected for blue and clear particles, and lower than expected recovery for orange and white particles. We also see that higher recovery was found for fibers and lower recovery for fragments. Next slide, please. Participating laboratories collaborated to analyze the data and answer other important questions. We had 8 working breakout groups that met numerous times over Zoom to untangle the complicated data sets we generated and provide guidance on important things like quality control, method feasibility, and laboratory accreditation. A significant achievement from one of the breakout groups was determining the minimum number of particles that would be needed for spectroscopic identification to get a representative sample. This analysis can dramatically reduce the amount of analysis time and therefore the costs. Next slide, please. So coming back to the size-based recovery, just zooming in here on looking at the total particles versus the particles that are larger than 20 microns, we can see more clearly that the recovery and the accuracy and precision is acceptable for particles greater than 20 microns and relatively tight for the all particles combined, but it's still much lower than what one would want. Next slide, please. So these 2 plots are showing the accuracy and precision as a factor of the laboratory experience. Novice technicians counted false positives more often than experienced labs, and in general, we see lower recovery and variability with more experienced labs. So what this is telling us is that after 1 year of experience, laboratories can get highly precise data, and they may be undercounting samples due to a more conservative counting. We also found that there were lower blank contaminations in experienced labs. Next slide, please. We also found that laboratory technicians who completed in-person training at SWRCB prior to the study and who followed the standard operating protocol had better overall recovery, as shown on the y-axis here. Next slide, please. This is sort of repeating a little bit of what I've just said, but this shows again the size-based accuracy, and this is actually for the spectroscopic identification of FTIR. So we can see here that the accuracy for this method for identifying plastic versus non-plastic is quite good for particles greater than 20 microns and highly variable for smaller particles. Next slide, please. A similar story is seen for Raman. In this case, we actually had some labs submit accurate data for the 1 to 20 micron fraction. And in general, we think that Raman is able to get much smaller particles than FTIR. Next slide, please. So this is a compilation of all of the information that we've collected on these 3 methods. And here we can see the overall strengths and limitations of these methods. We feel that we have 2 spectroscopic methods that are ready to use for drinking water analysis for microplastics, including Raman and infrared. Optical microscopy is an important step that's included in both of these analyses, but we need this spectroscopic technique to confirm whether or not it's plastic. As we can see with the accuracy of just looking at the particles and a human trying to tell if it's plastic or not is around 44%. So we really want to be sure that we're identifying microplastic particles and not something else. So we really need these spectroscopic techniques. In general, Raman and infrared are comparable in their precision and accuracy. The major differences here is that infrared tends to be a little bit cheaper overall with both the instrument and the consumables cost, while Raman can get slightly smaller particles than infrared. Next slide, please. Standardized methods based on Raman and infrared were developed as part of this study, and they're made available on the Water Board's webpage on September 28th. Before posting these methods online, we received a great amount of input from numerous outside experts from academia and government sectors. And we invite additional public comment on these methods until December 22nd. Next slide, please. During our analysis, laboratory participants acknowledged the high resource demands of using these spectroscopic techniques, and they proposed a tiered monitoring framework to save time and money. Under this framework, a rapid screening method would first determine if there's likely to be microplastics present in a water sample. Above a certain threshold, Bulk quantification of microplastics using pyrolysis GCMS or a similar method could then be used. When detailed particle characterization is required, Raman and infrared could then be used. Right now, this is just an aspirational framework that can be partially developed through our exploratory monitoring campaign, but we hope for this to be further developed through our work and as well as collaborations. Next slide, please. Laboratory participants evaluated some potential surrogate methods or tier 1 methods in one of the breakout groups. Numerous methods were identified with variability and feasibility. 3 methods are already being used widely for water quality monitoring, including turbidity, total organic carbon, and total suspended solids. Currently, our draft policy handbook identifies these 3 methods as being required for monitoring by water systems alongside microplastic samples so that we can determine through this effort if they could be suitable tier 1 surrogate methods. Next slide, please. At the end of the interlaboratory validation study, the laboratory participants voiced their support for a continuation of our collaborative work. We started the California Microplastics Monitoring Subcommittee of the Water Quality Monitoring Council this year, with the goal of building a local and global community exchange of information and data for microplastics monitoring methods and tools. We're meeting regularly and we invite anyone to join. Next slide, please. So now that we have identified the standardized methods that we'd like to use for monitoring, we can now develop an accreditation program for laboratories. Next slide, please. The Environmental Laboratory Accreditation Program, or ELAP, worked with laboratory participants in a breakout group to develop components for accreditation for microplastics analysis. We developed an inspections checklist, documentation, desired performance evaluation samples, and quality criteria for accrediting labs. While we have some materials available for testing laboratory performance, the ideal performance evaluation samples for microplastics in drinking water are currently not available. We hope that a supplier will step up to the challenge and make these samples available in response to our need. Although we don't have a performance evaluation sample available, ELAB can still confidently accredit laboratories. ELAB has a multitude of tools available for assessing laboratory capability and does not always need proficiency testing samples to accredit laboratories for methods. For example, drop digital PCR, flow through aquatic toxicity bioassays, and several other methods do not currently have proficiency testing samples, yet ELAB can still reliably provide accreditation for those methods. Also, PT sample providers often will develop samples in response to a need. For instance, when the DLR was lowered for 123 TCP, there was no performance testing sample available, but a provider stepped up to the challenge. Next slide, please. Currently, laboratories can assess their recovery and accuracy using certified reference materials available from the National Institute of Standards and Technology, or NIST. These include the Polymer Kit 1.0, which contains 22 commonly found plastic materials. Next slide, please. As well as the traceable size standards, which can be used for testing the particle count data from laboratories. Next slide, please. Senate Bill 1422 also requires that the State Water Board consider adopting a health-based guidance level to aid consumers in interpreting concentrations in drinking water. This includes the consideration of a notification level or similar type of level. Currently, the health impacts for microplastics for both humans and animals are not fully understood. Next slide, please. We partnered again with the Southern California Coastal Water Research Project to facilitate an expert workshop to assess the available evidence for impacts to humans and to aquatic ecosystems. Through this year-long effort, we critically assessed the microplastics toxicity literature alongside experts from around the world. Next slide, please. Our working group included representation from government, industry, and academia, with globally recognized experts in microplastics toxicology. Next slide, please. Our working group developed some screening criteria for assessing the reliability of studies, with 3 major categories of criteria applied. Starting with 29 rodent ingestion studies for microplastics, We identified 12 that are deemed fit for purpose for risk assessment. Of those 12 studies evaluated by subject matter experts, most of the reliable endpoints focus on impacts to male reproductive impacts. These studies show consistent effects across a range of particle sizes. After evaluating the evidence for potential impacts to humans through drinking water, our expert group concluded that significant data gaps prevent reliable assessments of risks for for humans in microplastics. They recommended that the State Water Board currently refrain from developing a notification level, but that a non-regulatory screening level could be developed for screening level purposes only. Next slide, please. Our expert group identified 3 major classes of problems that prevented them from recommending the development of a notification level. These problems include an inadequate effects database, with most studies poorly characterizing the particles that they're exposing the animals to, and using a very limited range of polymers, shapes, and sizes. Almost all of the studies were using polystyrene spheres, which don't represent the diversity of microplastics that we're actually exposed to. Additionally, we don't understand the toxicity effect mechanisms. This is really necessary for extrapolating from, say, a polystyrene sphere of 5 microns to a diversity of microplastics that we're all being exposed to. Lastly, there's an incomplete exposure database with very limited information on what's in our food and no harmonized drinking water data available. For this, we can actually fill this data gap partially through our monitoring campaign. Next slide, please. In lieu of developing a numerical health-based guidance level, our expert group developed some health-based guidance language that can be used to aid consumers in interpreting detections of microplastics in drinking water. The recommended language is as follows. Studies of rodents exposed to some types of microplastics through drinking water indicate potentially adverse effects, including on the reproductive system. However, more research is needed to understand the potential human health implications and at what concentrations adverse effects may occur. Therefore, California is monitoring microplastics in drinking water and supporting ongoing research. Next slide, please. Luckily for us, there's an exponential growth in the number of laboratory studies of microplastics hazards in mammals. Our research effort identified some significant data gaps and made recommendations for researchers to fill these data gaps in a high quality manner. Next slide, please. And this one's actually, there's a short video if you just want to hit the button. So to assist our workshop participants in evaluating the toxicity evidence, we created an interactive database evaluation tool that allows researchers and the public to query the database in numerous ways. This tool can help inform future studies, make inferences and perform statistics with existing data, and allows researchers to upload their published data in a harmonized way so that it reduces future workloads for meta-analyses. This is just a brief glance of the app, which is currently called Tomex, and it will be publicly available soon. Next slide, please. Meaning to stop the video and then hit next. There we go. The research we conducted for developing standardized methods, an accreditation program, and health effects directly informs our plan for 4 years of testing and analysis as required by Senate Bill 1422. Because no government in the world has ever required monitoring for microplastics in water, this will truly be a groundbreaking and trailblazing effort. Next slide, please. In designing a monitoring campaign, it's important to understand where microplastics are likely to be found. First off, we know that microplastics are unlikely to occur in most groundwater wells. However, they are likely to be found in most surface waters. Additionally, treatment removes microplastics based on the filter and the particle sizes. Most drinking water treatment plants that are using surface water as their source water use filtration methods to remove particles anyway. Flocculation and sedimentation can remove particles down to the single micron size. And more advanced filtration methods such as microfiltration, ultrafiltration, nanofiltration, and reverse osmosis can remove even smaller particles. Our Raman and infrared methods currently can reliably quantify microplastics as small as 20 microns. So they are unlikely to detect the sizes of microplastics that will make it through most treatment techniques. We know that laboratories can quantify smaller particles using our Raman and infrared methods, with some labs reporting microplastics as small as 200 nanometers. ELAB cannot reliably assess those laboratories' performance until we have a representative proficiency testing sample, which again, we hope will be developed in response to our stated needs. Despite these shortcomings, we can still use our developed methods right now to characterize the contamination in the source waters, which will be an instrumental first step in determining potential exposure to humans and characterizing contamination in the state. Next slide, please. Microplastics, like other particles, have predictable behaviors in the environment. As microplastics get smaller, they become exponentially more abundant. This relationship, illustrated through this data-driven histogram shown here, may be likened to an iceberg. If one knows the shape of an iceberg, they can measure the visual portion and reliably estimate the portion below the surface. So for microplastics, we have a pretty decent understanding of these size distributions in freshwater to particles as small as 1 micron. So we can use these to extrapolate to that size range in surface waters. Next slide, please. So in recognition of the limited laboratory capacities for monitoring microplastics, as well as the costs of monitoring and the uncertainties with regard to health effects, we recommend a targeted exploratory monitoring approach to assess contamination. This approach is similar to the US EPA's unregulated contaminant monitoring rule approach. We propose a 2-phase approach in which the first phase focuses on characterizing contamination in major source waters for microplastics that can be reliably quantified using our current Raman or infrared spectroscopic methods. The focus in phase 1 will be on characterizing contamination in the source waters that are used as drinking waters for the majority of the California population. Surface waters would be targeted due to their high likelihood of contamination. Water suppliers producing more than 10,000 million gallons per year and systems serving greater than 10,000 people will constitute the majority of systems receiving monitoring orders during phase 1. Additionally, during phase 1, several surrogate methods will be evaluated to determine if they can be used as a preliminary screening technique in further studies. Following phase 1, there will be a 6-month period in which State Water Board staff will evaluate this data to determine if source contamination is occurring and what factors may be what factors may be associated with that, and then further select some points for monitoring in treated drinking water. At this time, we anticipate that proficiency testing samples for microplastics will be available so that ELAB is able to accredit laboratories to quantitatively monitor microplastics smaller than 20 microns, which are expected to be found after some of these treatment techniques. During phase 2, surrogate monitoring methods will be used if there are any deemed reliable for indicating potential contamination from phase 1. Next slide, please. Across both phases, water would be collected using the ASTM International's standardized sampling protocol for microplastics. This technique is relatively simple and involves connecting a flow meter and flow control valve to a sampling tap, then filtering water through a stack of sieves. Collected particles can then be analyzed using our standardized Raman and infrared methods in a laboratory. Next slide, please. Senate Bill 1422 allows the State Water Board to implement the sampling and analysis plan through a policy handbook. We released a draft policy handbook on November 10th, and we invite written public comment on this handbook until December 22nd. The policy handbook sets the overall rationale and requirements for monitoring, and individual monitoring orders would be issued based on the rationale laid out in the policy handbook. Next slide, please. So I'll wrap up with some next steps for this effort. As mentioned before, the draft policy handbook and methods are open for for written comment until December 22nd. We'll also be conducting external scientific peer review for the methods and sampling plan with anticipated completion in March of next year. This is January, but we're expecting March. In the spring, we plan to come back to the board to consider adoption of the policy handbook. Additionally, the Microplastics Monitoring Subcommittee has ongoing meetings that are open to all, and we would like to continue our collaborative discussions with the community. We will also be training ELAP and third-party laboratory assessors starting in the spring so that we're ready to provide accreditation for laboratory methods starting next summer. And with that, I'd like to thank you, Chair Escabel and board members for your attention and consideration.
Thank you, Dr. Coffin. As Director Pohamis said here at the top, it is an incredibly exciting field right now. And I appreciate the careful and cautious approach here because we are so bleeding edge and really at the start of so much of this work, setting standards, just even being able to, in basic terms, assess what the challenges are in even detecting microplastics, let alone coming to conclusions around public health. And know that there's a lot of concern, though, from communities and others around what microplastics may be doing to health in amongst what we know are many constituents that we have to take in consideration here at the board. So just thank you. I know it's been very innovative work, nationally recognized at this point, internationally, that is, and it's going to take teams of international researchers and others to help us really best understand the impacts to health and the ways that we can then at some point try to get to address it. But the phased approach makes a lot of sense. And again, it's a product of the fact that we are on a very bleeding edge topic here, but glad that the dollars and resources that we are putting toward it, I know are going to open data and contributing to a field of research that I think California is proud to have the resources to even engage in. And so just thank you. I don't think I have further question at this point. I know in my briefing, I and can bring up, I was interested in the differences between Raman and infrared, and ultimately looking at if this work is continue to scale out, the costs relative, and Dr. Coffin covered some of that. So it'll be interesting to see this work, and I look forward to the adoption of the actual policy handbook. Board members, any questions here or comments off the top? And let's see, I think we have somewhere around just about 5 or so commenters, so we can go to any questions or flags that they may have before further discussion.
I just have a quick question. Dr. Coffin, thank you for your presentation. I think very articulate, and agree the plan that you proposed sounds reasonable. I'll, of course, look forward to hearing stakeholder input and feedback on what you've laid out here. But just to clarify, I think you mentioned the external peer review process will maybe slipping a bit. So will that also push back the policy handbook adoption that you showed on the slide there, or would that be after the peer review process? Thanks.
Yeah, go ahead, Scott. I'm not sure on the timing, so please go ahead and answer.
Yeah, so the March is sort of an anticipated final date. We're getting everything finalized to submit to the external peer reviewers, hopefully before the Thanksgiving break. So they should get it back before March at the latest.
And I'll just comment as well that we have a proposed schedule put forward in our policy. It is somewhat aggressive. I think we're going to have some really good comments to consider from the folks that will be doing the monitoring, and we really do want their input as to what makes the most sense. We're not trying to rush this by all means, but we do want to keep it moving. And so I do look forward as well to the comments from those that will be participating in the program and moving forward as to what would make the most sense as far as their expertise goes.
Okay, yeah, thank you. And that was my only concern, is that we're just providing enough time and space for our peer reviewers, for you, to absorb any input that's provided, and not rushing into the adoption if a little bit more time is needed. That would make sense to me.
Yeah, no, certainly that's the case. There could be other things too that we want to hear from some of our large water systems that would be the ones doing the testing, and hopefully we get some comments, both written and maybe today, around their own training, acquisition of equipment, and stuff like that. We're definitely want to make this a partnership with them, so that'll be important to hear.
Definitely. Thank you.
Great. Any others? And Board Member Morgan, do just chime in since I don't have a visual cue. Okay, great. Then let's move on to our first commenter, Allison Markova. Good afternoon.
Good afternoon. First of all, thank you for the opportunity to comment. I am the Associate Director for Technology Transfer at Woods Hole Oceanographic Institution. And WHOI, as we call it, has been doing quite a bit of work in microplastics research and development of detection sensors. And so I really quickly just wanted to introduce some of the projects that are underway at the institution. We've been following the work happening in California, and although what I'll discuss in a few minutes was developed for oceanographic research, we think that it could have application and use for many other things, including drinking water. Next slide, please. So really quickly, if you're not familiar with Woods Hole Oceanographic Institution, we are a nonprofit ocean research institution based in Cape Cod. And we have scientists and engineers studying all areas of the ocean: biology, chemistry, physical oceanography, and microplastics has been a very hot topic in recent years. Next slide, please. Our department at WHOI, the Department for Technology Transfer, handles IP protection and commercialization of research innovations coming from the research labs. So I was hoping that the scientists involved in this project could present today, but unfortunately they are at sea on a research cruise with very limited internet access. So I am here instead just giving a quick introduction. Some of the projects happening involve understanding the fate of microplastics in the ocean, gauging impacts on marine life, and then also engineering new technology solutions. There's a whole website dedicated to the work happening at WHOI. It's microplastics.whoi.edu. Some of the other current projects involve studying how plastics biodegrade in the ocean. And then what I'd like to introduce today is the design and construction of a field portable rapid analysis microplastics detection sensor. Next slide, please. Two scientists at WHOI have developed this sensor, and it's microplastics detection via impedance spectroscopy. The goal was to create a small, inexpensive inline sensor that was lower cost than a couple of the other methods that Scott discussed earlier, such as Raman or infrared. Again, it utilizes impedance spectroscopy in a flow-through system, and it delivers microplastics quantification in real time. There's currently a field prototype in development, and again, it's hopefully going to be designed to be low-cost, durable, portable, and again, this was designed for oceanographic field research, but we believe it could have application elsewhere. Next slide, please.
Ms. Markova, I don't mean to interrupt, but do you know to what size the detection is on that sensor?
I believe so far they've tested 200 to 1,000 micrometers,
Okay.
but that could be dated information.
Okay, thank you. That's very helpful. Thank you.
The two scientists involved are Dr. Anna Michelle. She's an associate scientist in the Department of Applied Ocean Physics and Engineering, and Beckett Coulson, who is a WHOI MIT Joint Program student, also in AOP&E at WHOI. Next slide, please. So as I mentioned earlier, there's been some initial testing conducted in freshwater. There's been at least 2 published papers, a field prototype in development, and some of this work has been funded through philanthropic organizations. There are 2 pending patent applications for this technology, both the detection method and then the identification of the microplastics. And we're currently looking for commercialization and development partners. Again, we're a nonprofit research institution. We don't manufacture or commercialize products, but we do work with outside companies in doing so. Next slide, please. So I just wanted to provide my email and our department's email. If you're interested in learning more about the work happening at WHOI, we would be happy to have a follow-up conversation or get the scientists involved on a call. Thank you very much.
Thank you, Ms. Markova. I really appreciate the presentation and the collaborative space that you're all contributing to with us as well. It's didn't get a chance to touch on it, but what I really appreciate about this work is a continuum to macroplastics and our trash policies and our real concern about how this whole life cycle of plastics is impacting our water quality. And so the work that you're doing in detecting and quantifying plastics as they occur in oceans and the cross collaborative space around sensors and technology is just really appreciated. So thanks for the work that you all do, and thanks for joining us here and providing comment today.
Thank you.
Next, we have James Rusi.
Thank you. I appreciate the opportunity to present commentary to the board today. My name is James Rusi. I'm the Chief Scientific Officer at Simpor Incorporated in Rochester, New York. Simpor manufactures and develops technologies for microplastics capture and analysis. We participated in the SWRCB methods evaluation study. We also participated in the surrogate tiered screening methods evaluation committee. I wish to underscore several of the important points of Dr. Coffin's presentation today. First, the tiered surrogate methods are very likely to eventually provide a low-cost means for routine microplastic monitoring. And second, the standard methodologies and the SOPs that have been put forth so far are invaluable guides, both for microplastic monitoring as well as the broader microplastics concerned research community. As Dr. Coffin pointed out many times, those standardized methods have indeed validated methods for detecting, monitoring microplastics that are 20 microns and larger. And with the potential health effects of smaller microplastics being those of greatest concern, and the state's phase 2 plans for monitoring microplastics as small as 5 microns. Wanted to highlight the need that a similar effort needs to be repeated, if you will, for validating the 5 to 20 micron size range microplastics. So for instance, having identifiable pathways in place, both for developing as well as validating new technologies and methods will be very important for the phase 2. And developing these pathways for development and validation could take on sort of a repeat of the SCCRWP-like study in the future. As I said, my company is involved in developing manufacturing technologies for these kinds of needs. And we would really appreciate, companies like myself, other entities would very much appreciate having those identifiable pathways for development and validation in place in support of especially the phase 2 5 to 20 micron microplastic studies that will be happening in the forthcoming years. Thank you for the time. I appreciate the opportunity to comment.
Thank you. Really appreciate the comments and engagement. And thank you. Really appreciate the time.
Thank you.
Next, we have Nick Blair, who will be followed by Teresa Slifko.
Thank you,
Good
Chair
afternoon.
Esquivel. Can you all hear me? All right. Very good. Good afternoon, Chair Esquivel, board members and staff. I am Nick Blair. I'm a regulatory advocate with the Association of California Water Agencies. Thank you for holding this workshop and allowing stakeholder feedback in the process. We appreciate the hard work by staff and SWRC and the willingness to have these conversations as the regulation and draft handbook are developed. To reiterate what we said in a past comment letter, we say it's important to make sure that we take the time to work through this cutting edge topic correctly to ensure that the methodology and monitoring requirements are developed effectively to keep folks informed on the content of their source drinking water while also maintaining confidence about the safety when it is safe to drink. I will try to be brief since we are going to also submit written comments on December 22nd. So first, we really appreciate the reference in the draft handbook to the importance of cost considerations for public water systems. We encourage consideration of making funds available for agencies selected for inclusion, either from SAFER or from elsewhere. We have a few recommendations at this point to alleviate some concerns. First, we request clear implementation guidance in the draft handbook. Namely, we want to revisit the consistency of reporting limits, procedures, analytical methods, and tools as they become available. We also want to request guidance of what to include in the CCRs for results on delivered water to customers. And we want to request reassessment of needs for phase 2 after phase 1 is completed in case there are any new important revelations that come out of that. Additionally, we'd like to request some timeline flexibility for implementation to address supply chain issues, as well as providing time for laboratory analyses and validation to be finalized, and also as we get more clarification on the reporting requirements. So given these recommendations, we had an idea to go with this cautious, careful approach. We wanted to propose an initial exploratory phase ahead of phase 1 to develop, validate, and pilot test sampling and analyses methods. We think this step could serve as a planning and experimental phase to get everything set up and operational before monitoring commences. And to further describe, we think this step would provide some flexibility with the schedule to give us time to acquire the necessary resources to set up and validate sampling and analyses equipment. Also, time for agencies to set everything up for monitoring and report data under the order, while also accruing experience for sampling and analyses, and time for labs to get ELAB certified under TNI standards. So we look forward to continuing our work with staff on development of the methodology and monitoring requirements. We'll further elaborate on everything I just said right here in written comments. And we appreciate the emphasis by Dr. Coffin and Director Pohamis on collaboration with public water systems, as we definitely want to be a part of this process. So thank you for your time.
Thank you, Mr. Blair. I appreciate the recommendation, taking into consideration here and thought, and look forward to the full response from ACWA on issues. And I just thank you for the engagement. We'll continue to be sure and have that as a central component of all of this work that we're doing. So thank you. Next, we have Teresa Slifko.
Hi, everybody. Good afternoon, members of the board and representatives of. Can you hear me okay?
I can. I'm sorry. I said good afternoon. Yeah.
Yeah. Hi. My name is Teresa Slifko. I manage the chemistry unit at the water quality section at the Metropolitan Water District of Southern California. Metropolitan is a regional wholesale water agency that provides drinking water to 26 member agencies representing nearly 19 million people in 6 counties. We operate 5 drinking water treatment plants with a combined capacity of over 2 billion gallons of water per day. We appreciate this opportunity to provide initial comments, and we also appreciate the board's transparent scientific process and Dr. Scott Coffin's engagement with stakeholders. Metropolitan has been tracking these issues related to microplastics and the board's response to Senate Bill 1422 since 2018. We work closely with the research team assembled by the Southern California Coastal Water Research Project to evaluate microplastics methods, and we were the only drinking water agency that participated in the study. The other study participants represented an international group of scientists, government, and private sector labs with expertise in ecology, environmental toxicology, ocean waters, and clean water objectives, and others. While the participation of public water systems was limited, the collaboration provided an excellent, transparent process for evaluating microplastics methods for a variety of applications. We recommend that a subsequent phase of method evaluation should include a greater focus on drinking water. Metropolitan recognizes that our collective understanding of the occurrence and human health effects of microplastics in drinking water is developing, and more information is needed. We support advancing the scientific process to provide clarity on the prevalence of microplastics in drinking water and the level of risk to human health. We also acknowledge and appreciate that the board recognizes, based on initial preliminary studies, that existing drinking water treatment processes effectively remove microplastics. To support the board's plans for moving forward, we offer the following specific comments. The development of scientifically sound, technologically and logistically feasible analytical tools remain a significant challenge for microplastics monitoring. It is our understanding that no California water utilities have the instruments required to perform the microplastics analysis, nor do they have experience collecting samples or performing either of the complex methods included in the monitoring plan. We understand that the two analytical methods proposed in the board's plan are being updated to reduce processing time and improve sensitivity. However, we feel it's important to note that the study of microplastics in water is an active research field. Scientists and policymakers need enough time and resources to collect appropriate information to properly inform the next steps. The current plan timeline is aggressive, and it does not consider instrument budgeting and acquisition, availability of supplies, or method validation and accreditation, which collectively may take up to 2 years to complete or possibly longer. Therefore, we suggest that the board incorporates flexibility into the monitoring schedule to ensure that water systems and laboratories have sufficient time and resources necessary to establish and validate sample collection procedures and analytical methods, especially if ELAP accreditation is required. Also, we urge the state to consider an option in the monitoring plan for an initial exploratory phase to properly develop, validate, and pilot test the sampling and analysis methods prior to collecting monitoring data. We feel it is appropriate that the monitoring program takes an iterative approach and is supported by a multi-phased research effort to improve the accuracy and reliability of the monitoring results. In addition, we recognize that the methods may not be practical for routine use, so we support the development and use of reliable surrogates. The working group that was recently convened by stakeholders to develop a project to evaluate potential microplastic surrogates for monitoring drinking water is good. To be successful, this study needs financial support from the board and oversight by a peer review process. Finally, Metropolitan urges the board to provide clear implementation guidance and public communication tools that consider the context and human health risk, particularly if the monitoring results are to be included in consumer confidence reports. Without the proper context, the presence of microplastics in water, particularly in untreated drinking water, could easily be misinterpreted, which could erode public confidence in the quality of drinking water. So in closing, we appreciate the board's support for advancing the science and understanding of microplastics in water, and we are especially grateful for the collaborative process and look forward to working with everyone on this important issue. And we would provide more detailed written comments to expand this brief summary. So this concludes my comments. Thank you.
Thank you so much, Ms. Slifko. I really appreciate the engagement and comments here from the Metropolitan Water District, an important partner in this project. So thank you.
Thank you.
Next, I'd like to call up Jennifer Lynch.
Hello.
Good afternoon.
Thank you. Thank you so much for allowing me to attend and speak at this. I am a federal employee with the National Institute of Standards and Technology. I am based out in Hawaii at the Hawaii Pacific University Center for Marine Debris Research. And I just want to thank the state of California for this work. It is fantastic research that has been undertaken, and it really is meeting some national and global major research gaps. So I wanted to state my thanks for that. NIST, the federal agency that I work for, makes standard test materials and proficiency test materials. And we just heard in the presentation that there is a need for this. We at NIST have recognized that the field of microplastic research needs a very diverse set of microplastic materials for this kind of research. And it's quite daunting to even begin. And I think we are still seeking as a federal agency what the community needs. And so hearing from the state of California, a very specific microplastic size, polymer type, in what kind of packaging material would be very helpful. Next slide, please. So I have to disclaim that anything I say in here does not imply recommendation or endorsement by NIST, and anything I say in here does not it's not necessarily the best available for its purpose. Thank you for that moment of disclaimer. Next slide, please. So material standards are very important. NIST makes these. The picture on the top is one of them. They're physical, tangible materials with well-characterized composition or properties that support accurate, comparable, and compatible measurements. Next slide, please. I've queried our website for what kind of plastic standard reference materials NIST produces currently. We have 20 different materials of 7 resin types. I believe I have animation. Can you click the next to see if it's working? Yes, okay. So there's the website. The list of materials that I can find on our website are highlighted with their 4-code catalog number. Next, please. Next. There are 6 different resin types, and I really want to point out that we're missing a lot of polymers. We're missing polyethylene terephthalate, your disposable drinking water bottle. Next, we have some with certified additive levels. Maybe go quicker through the next. A lot of the, keep going. 10 are in pellet form and 6 are in solution form, shown in that box right there. And they are of size classes that might be interested by California. However, most of those are polystyrene and very odd polymers. Next slide, please. Next. The Hawaii Pacific University Center for Marine Debris Research, of which I'm also the co-director of, produces this polymer kit that is an easily obtainable, affordable kit of 22 different plastic materials. It offers the diversity of polymers, but it does not offer the size diversity that most people are interested in. And so we understand that people need more. We're listening. We want to engage. And I really would suggest or recommend that NIST and the California Water Board and SWRCB get together and talk about this and see how NIST could meet the needs. I believe that's my last slide.
Thank you so much, Ms. Lynch. Really appreciate the great work here with us on, as we've all noted, is very cutting edge and bleeding edge and needing all of us to figure out how we fill these data gaps and all contribute our roles. And certainly NIST has been and is here doing just that. So just thank you for that partnership across here, certainly the state and then federal family. So I think that is a fantastic recommendation insofar as having, and here, knowing that we're trying to make sure we're preparing our ELAP labs and want to ensure that we have the supply chains in place that allow us to do this work confidently and know that we aren't just going to run up against, because it's such a cutting edge space, issues that we could maybe work out here better between ourselves. So thank you for that recommendation. I support it for sure. And just thank you for contributing to today's discussion, let alone the ongoing project. Next, I'd like to call up Amy Gilson.
Hi, good afternoon, Chair.
Good afternoon.
Hi, and thanks for the opportunity to provide public comment today. My name is Amy Gilson, and I'm the policy manager with Californians Against Waste, California's oldest recycling, composting, waste reduction environmental organization here. We welcome the board's groundbreaking work developing standardized methods for microplastics testing and a reporting plan for microplastics in drinking water. And clearly, as we've heard today, this work is unique in the nation and the world, and really pushing forward the science and methods, which we think will, even though we're focusing on drinking water today, advance our ability to get our arms around microplastics in freshwater, marine water, even have much broader applications. And that this is something that will be really useful for us as we figure out how to tackle source reduction of microplastics and plastics upstream, as you were just mentioning, this life cycle of plastics and trash. So we look forward to seeing what we learn from the monitoring and continuing to follow the board's efforts, and want to thank you again for this tremendous work.
Thank you, Ms. Gilson. Just here. Plus up on all your comments, and look forward to just that the important contribution that this is giving to what is a larger plastics discussion, but the opportunities for that cross-pollination, as we've already heard from some of our previous commenters, is just a really exciting part of this. So thanks for being part of the project and and contributing so well to this discussion. So thank you.
Thank you.
Next, we have Emily Parker. And then if Ms. Parker is not available, we have Miho Ligare.
Great. Hi, good afternoon. My name is Miho Ligare, and I'm the Plastic Pollution Policy Manager with the Surfrider Foundation. Thank you for the opportunity to provide comments. And I think that protecting public health and the environment needs to be a top priority, as evidence concerning the hazards and exposure of human and microplastic is nascent and rapidly evolving. We're in support of monitoring microplastics in drinking water now using the best available science. And we really appreciate the support the Water Board's leadership, especially with Dr. Coffin. Thank you so much on developing these monitoring protocols. This is a great first step, and monitoring should happen. I also want to point out, as my colleague Amy also mentioned, that this is also a great opportunity to start thinking about monitoring and using this opportunity to monitor water, not only for drinking, but for freshwater and marine ecosystems, and really start thinking about this life cycle and source reduction. And we really look forward to staying engaged, and we'll send more detailed comments next month. So thank you for your time.
Thank you. Really appreciate the engagement and good comment. I think unless Emily Parker is on the platform, that leaves us at the end of our commenters. So thank you everyone for contributing to today's discussion and workshop. Board members, thoughts, reflection, further direction. I interestingly did hear a request from a couple of our stakeholders for more of an exploratory phase before entering phase one, or some pre-phase that prepares us for the work of phase one. I'd be interested in, I'm sure that there will be plenty of work that goes on, whether we officially have a pre and or exploratory phase before phase one is triggered there. But I'll just say I find it interesting, open to thought around it, but did hear that, I think, clearly from a couple of folks. I think the balance here is definitely there is an urgency in wanting to keep the momentum and contribute to what is a very important plastics discussion. And this is such a critical component. So I think we need to have that. And I think we have acknowledged as well at the same time that we are so at the edge of these things, that there are a lot of questions that still need to be answered as part of our ability to move forward with confidence, and to ensure that we are providing just a good basis of discussion around the threat of microplastics to drinking water, and not jump to conclusions that we can't yet make. And I think we're being careful in doing that. What I'm hearing is further desire for cautiousness and space before we enter even phase one here from some of the water agencies particularly. And I can understand that. And again, I think it's that balance that we're having to strike on the work. And at this point, just open to further discussion around how we see it. So that being said,
I thought it was a good point too. Thank you, Chair Esquivel. I agree. I think I'm wanting to hear more about how this might work, whether it's a pilot phase or how the staff proposal would ramp up and be implemented. Just the concerns about the time to get the labs up to speed here, getting the accreditations done, the equipment in place, the cost factors. I think those are all good points that we should think through. And so it does lend some merit to maybe breaking this out in smaller chunks if there's some folks who are ready to go in the shorter term, and maybe others might take a little bit longer to get up to speed. So anyway, I think just good comments, and look forward to continued thoughts in the written comments when they're submitted.
Other board members?
Well, just on that issue, I feel like I would like to understand it more. So I think that's what both of you are flagging as well.
Yeah.
So
Yeah.
I don't know that I support it. I think I more just want to understand it.
Likewise.
Great. Great. And then just thank you. I think incredibly well thought out and careful work that we're trying to do collectively in this state and really across the world, and trying to think about and understand better this problem, and helping us get some tools in place to understand it better, faster. I think really important concerns around how we communicate the information that we're learning. We don't want to confuse people or cause more problems. And we also want to share information that and our learning as we go. So I think just very thoughtful work and points by stakeholders and staff, and look forward to written comments and keeping things moving forward.
Thank you, board member. Any other thoughts? Okay, hearing none. Thank you. Well, I think that can conclude this workshop then. Just again, an incredible appreciation to everyone's work here in this space. It's exciting to be part of what's a real research forward space. I think of a number of areas that the board is very benefiting from this really just incredible academic focus around water issues, water challenges, and the resources being brought to bear and all of that. And so it's fun and exciting to have a project that's so specifically in this research space, but reminds me of just how critically dependent we are on the academic and research community. And I think of many other projects out there, certainly through SWRCB, one of our more principal and great agencies out there. And so anyway, just thank you, everyone. Workshop, I think, here can be concluded. And just thank everyone for their time. This concludes our 2-day board meeting. Our next meeting is in about 3 weeks, I believe, but will be December 7th. So until that time, everyone have a great Thanksgiving. At this time, this board meeting is now then adjourned. Thanks, everyone. We'll see you soon. Take care. Bye.